Welcome to this virtual tour on winter wheat fertility trial. I am Bijis Maharjan, Soil and Nutrient Management Specialist at the Panhandle Research and Extension Center. Deepak Gimire is a graduate student in this project. Nitrogen is a key component that affects grain yield and protein content in wheat. In recent years, we saw increase in grain yield, particularly in wet spring years. But without optimal nitrogen supply, there were reduced protein content reported to a level where discount at elevators kick in. And as this chart shows, excessive nitrogen supply also doesn't necessarily lead to increase in grain yield, as it can lower nitrogen use efficiency and increase environmental nitrogen losses. Therefore, we have to optimize nitrogen management in such a way that yield gain and protein content can be simultaneously achieved. In addition to nitrogen supply, another factor that plays into grain yield and protein is timing of nitrogen uptake. Early uptake of nitrogen all the way up to jointing is important for tillering, which determine the eventual yield. Therefore, it is generally recommended to add nitrogen fertilizer before jointing. Late nitrogen uptake is utilized in protein formation. Therefore, besides nitrogen rates, the timing of application would be important to explore in order to achieve the result of good yield and protein. In order to evaluate the effects of nitrogen rates and timing on winter wheat grain yield and protein, we initiated field trials at 4 different locations in Nebraska in 2018. One of them is at High Plains Ag Lab in Sydney. We do have the same trial going on this year as well. Before I show you the field, let me explain a bit about the experiment. We have 2 varieties, Ruth and Freeman. We have 6 different rates of nitrogens, 60 pounds being the 100%, and 3 nitrogen application timings. Ammonium nitrate was the source of nitrogen, which was surface broadcast. This is High Plains Ag Lab wheat fertility trial this year. 60 pounds was 100% recommended nitrogen rate. We have 3 application timing besides 6 nitrogen rate treatments. As we walk down these 6-row treatment plots, there are no visually distinguishable differences among nitrogen treatments. And we have to keep in mind that this has been very dry spring this year, unlike last few years. In addition to nitrogen, water is very critical for winter wheat crop development. If you look closely though, we could notice slightly more tillers in high nitrogen treatments than in no or low nitrogen plots. Here you can see 100% nitrogen, which is a 60-pound nitrogen plot, and control plot. The high nitrogen plot obviously appeared to be more denser, and the tiller numbers were greater compared to the control. This is the weather map showing the departure in precipitation from long-term normal precipitation for the last 6 months. Most of the parts in the state seem to receive less than normal precipitation in last 6 months, and same is true for High Plains Ag Lab area as well. And this will definitely play into the wheat production we would see this year. This year wheat is yet to be harvested, so if you will, I would share a little bit, if you haven't seen the data from last year field trial. When we look at the bushels as affected by the nitrogen rates, there was pretty good linear relationship. The highest rate, which is 75 pounds of nitrogen, gave little under 60 bushels. But again, economics do have to be factored into here in order to make sure that for every increment of nitrogen input, you are getting the bushels that would justify that additional input. Grain protein were also affected by nitrogen rates, although the data differences are statistically different, but the grain protein under different nitrogen rates were within the range of 11 to 11.5%. Certainly we need to do much better so we can get a little more on grain protein. We didn't see any effect of application timing on grain yield or grain protein. So this was a little bit surprising to me, but we have to acknowledge this particular field did get a little bit hit by a hailstorm during the season. That might also have been a reason for some of the crop performances under different nitrogen treatments. With respect to variety, Freeman gave about 5-6 bushels more last year compared to Ruth, but at the same time, Freeman had about 0.2% less grain protein compared to Ruth. So we also have been testing the potential use of crop sensor in winter wheat nitrogen management. From the last year, we learned the vegetative index NDVI generated from crop sensing on winter wheat really differed by applied nitrogen rates, and there was a good linear relationship with nitrogen rates, which demonstrates that there is a potential for the use of crop sensor in winter wheat, if you will. To summarize, we saw the yield increase with input was pretty linear. It didn't plateau last year. Last year, if you recall, we had a good spring moisture, which is really different this year. So probably this may not stay true this year, but at least based on last year data, we saw application of input as we increase, yield bushels were increasing. It never plateaued up until 75 pounds of input. At the same time, there were some hail damage during the season, so that could have masked the potential benefit, particularly of nitrogen application timing. That's why we do need several site years data so that we can make a good conclusion that would benefit the producers in terms of managing nitrogen in winter wheat. And we had an encouraging data set to illustrate the potential use of crop sensing in winter wheat. We'll continue that work. So this is the second year data, so please stay tuned in for compiled 2-year data that to be presented to you sometime at some other avenues or through online platform. Thank you. Thank you for your attention, and if you would like to chat about the trial in more detail, if you have any questions related to soil and nutrient management, please feel free to contact me via my email or phone call. Thank you again.